Yeah, hello everyone. Myself Maruti. Welcome you all to Ram Maruti Tutorials. Right, in this video, I'm going to pick a sum from real numbers. Right, and in that real numbers, I'm going to deal to prove how a even number look like, how a odd number look like, but using Euclid divisions algorithm from real numbers chapter. So here comes the question for you. Real numbers show that every positive even integer is in the form of 2q, even integer in the form of 2q, and every odd positive integer is of the form 2q plus 1. We are dealing with the two things: even number in the form of 2q and odd number in the form of 2q plus 1. But the condition using Euclid division lemma or Euclid division algorithm. Okay, so let's work on that one. So let us start the sum. Before getting that, so we'll write if a and b are, we are taking two integers. If a and b are two positive integers, right, we are taking two positive integers. Which are those? A and b. We are taking two positive integers. Okay, such that how they should look like, right? A is greater than b. A should be always bigger than b. Right, now when a is divided by b, right? What we are taking? We are taking a, right? Example I like to show you here. We are taking a and we are dividing that by b. Right? We have taken two positive integers a and b, and what is the condition? A should be greater than b. A should be greater than b, and what we are doing? We are dividing a by b. Of course. Now when we are dividing a by b, we will be getting two things: the quotient and the remainder. Which are those? Let us consider them. Right, when a is divided by b, let's q be the quotient, q be the quotient, and r be the remainder. Right, so we have taken two things: a and b. A is dividing b, q is the quotient, r is the remainder. Now, what does our Euclid division lemma say? According to Euclid's division algorithm, right? According to Euclid's division algorithm, what is the formula we are having? A is equal to bq plus r. Right, that's it. So what we are taking here, it is nothing but the q and the remainder is r. Right. What he says, the a if you take it here, b into q, that is b into q plus r, means we are multiplying these two. Right. Then the result, the product what we are getting, bq when we multiply, for that we are adding this. Therefore we are getting a equals b into q, that is bq plus the r. This is the Euclid division lemma, or we are applying that as algorithm here. But here the condition is where this is the main condition. The remainder whatever we are getting should be always less than b. The remainder whatever we are getting should be less than b. Remainder should be always less than b. Of course, remainder will be always greater than 0. That is, remainder is greater than or equal to 0. This is what is Euclid division lemma. If a and b are two positive integers, a is greater than b, and when a is divided by b, q is the quotient, r is the remainder, then a is equal to bq plus r. This is the Euclid. Now, what we are supposed to do? We are applying this division algorithm to the question what he has given. Applying, right, what that? Euclid division algorithm for what? For a is equal to a only, right? We are not changing anything. A is equal to a, but what is the number he has given here? 2. Right, see here, bq. We are having bq, means in the place of b here, what is the number they had given? 2. So let us take 2 in the place of b. Right, b equals 2. This is the condition. Okay, Nana, we are taking A in the place of A, and here in the place of B, we are having 2. So we are taking 2, means we are applying this for this one, right? Now goes to the formula. Now how can we write? Then it can be written as, how to write that? It can be written as, how is that? A is equal to 2q plus r. So have you seen what I have done? So in the place of B, we got it as 2. In the place of B, we got it as 2. But what is the remainder? That's what the condition is. Well, then, remainder, comma r equals, what is that? It should be less than B. Who is B here? 2. What are the numbers which are less than B? 0 and 1. R is equal to 0 comma 1. So the reminders, they are less than 2. Which are the numbers less than 2? 0 and 1. So let us apply reminders into the sum and check it out what is happening. Now case 1. Right, R is equal to 0. If you take R as 0, how the sum becomes as? When R is equal to 0, then, right, RA is equal to 2q plus, what is the reminder we are taking? It's nothing but 0. R is equal to 2q plus 0. We can write it as R is equal to 2q. Now, can you please tell me how it is looking like? We know by definition of even numbers, any number which is looking, any number in the form 2n, right, is even. Any number in the form of 2n is an even number. Therefore, what we can say that A is, which implies A is even. Right, A is even, and it is in which form? It is in the form of 2q. It is in the form of which is equal to 2q is even. That is what we have proved. Now let us go for case 1 is completed. Let us go for case 2. What is the case 2? Here what we have taken? We have taken in the place of R, we have taken 0. Now let us take when R equals 1. So let us substitute 1 in the place of R. What does become? Then what is our A now? A equals 2q plus 1. Right, A is equal to 2q plus 1. Now, if you check it out, by definition of or, right, any number in the form of 2n plus 1 is odd. We know that one. Any number in the form of 2n plus 1 is odd number. Now, how this is looking like? So A is equal to 2q plus 1. It is in the form of 2n plus 1. Therefore, A is equal to 2q plus 1 is R. So, what we can conclude? We can say that any number in the form of A is equal to 2q is an even, and any number in the form of A is equal to 2q plus 1 is an odd number. So, hope you are able to understand. If you want, I can recap for you. We are using Euclid division lemma and we are proving how an even number looks like and how an odd number looks like. So, we are writing the Euclid division lemma. Here we have taken two numbers which are nothing but integers here. We are taking A and B as two integers. Alright, what is that? The condition? A should be bigger than B. And when A is divided by B, our guessing Q is the quotient and R is the remainder. Okay, you know that one. Now, this is the general mathematics, right? This is Q and this is R. Then A is equal to, if you multiply this corner with this one, that is B into Q. If you add this one, we'll get back A. Alright, but the condition is, the remainder what we are getting should be always less than the person who is dividing. Who is dividing here? B. So, that is what is the remainder should be always less than B or greater than 1. So, now we are applying this algorithm for the number which are present here. That is, in the place of B, we are having 2. So, A is equal to A and B is equal to 2. I am applying there. So, if you keep R in the place of the remainder here is 2 or B is equal to 2, what are the two numbers we are getting? 0 and 1. If you keep 0, it is in the form of even number by the definition of even, and if you place 1 in the place of R according to the definition of odd numbers, it is in the form of odd number. So hope you are in this channel. I have been placing both math and science videos.